Hello everyone, this is your tutor AB. Today we're going to be solving a problem from the ibphysics HL May 2024 examination. This is a paper 2 problem and it's from the time zone 1 paper. This is a thermal physics problem. Okay, let's get started. In a simplified model of energy balance of the earth, there's 3 bullet points that they want us to read. The surface of the earth absorbs the incoming solar radiation of average global intensity I0. The surface emits thermal radiation of average intensity I1, and some of the radiation emitted by the surface is absorbed by the atmosphere and re-emitted towards the surface. The average intensity of this radiation is I2. Okay. So they want us to explain the effect of an increase in concentration of greenhouse gases in the atmosphere on I2. I2 is basically what is re-emitted back onto the surface by the atmosphere. Okay. Now this is simply based on the concept of greenhouse effect. Now what is the greenhouse effect, you might ask? Greenhouse effect is essentially the idea that the sun will emit some radiation towards the earth and the earth will absorb this radiation. Okay, and in turn the earth will try to emit this radiation back in the form of a surface radiation. Now due to our atmosphere, some of this surface radiation is actually absorbed, not all of it leaves our atmosphere. And the radiation that's absorbed is re-emitted by the atmosphere onto the earth, onto the surface of the earth. And this is the reason that the earth has some temperature. Otherwise, earth would have no temperature, right? Whatever is radiated onto the earth is reflected back. But that's not how that works. Some of it is captured by the atmosphere and re-emitted back onto the surface of the earth. Now that's the simplified concept of the greenhouse effect. That's basically what they've highlighted here. Okay, that's basically nothing but the greenhouse effect. Okay. Now, let's basically answer this question using the concept of the greenhouse effect. So we can basically say increase in concentration of, we'll just call it greenhouse gas, GHG, put this in quotation, will allow for greater absorption of surface radiation by the atmosphere, and in turn there be greater intensity of radiation emitted onto the surface. And this is nothing but, so in turn just basically I2 increases. Okay, so the idea is that the greater concentration of greenhouse gases there are, the greater the atmosphere's capability to absorb the surface radiation, and so the more surface radiation is absorbs, the more it will emit back onto the surface of the earth, and so the intensity I2 will have to go up. Okay, now the next question. Sorry, this is from before. Remove that. Okay, the following data are given. I0 is equal to 240 watt per meter square and I2 is equal to 150 watt per meter square. Determine the average temperature of the surface of the earth according to this model. Now, we need to understand what is the net radiation or net intensity of radiation on the earth. Well, we have basically I0, which is constant due to the sun, and we have I2, which is constant due to the atmosphere. I1 is, and because some of it will actually leave, so the only two incoming radiations is I0 and I2. So if we add these two up, we'll get the net intensity of radiation on the earth. We can say net intensity of radiation on earth is basically going to be I naught plus I2, which is basically 240 plus 150, which is 390. Okay, and we'll worry about units later. This is the net intensity of radiation. Now we know a formula for which we can use here, which has temperature and intensity, that is L is equal to sigma A T to the power of 4. Okay, now you might be asking, we don't have A. Well, it's not necessary. Why is it not necessary? Because intensity I is nothing but L over A. L is nothing but power. L over A is intensity. So we can basically just replace this expression right here by saying L over A intensity I net is equal to sigma T to the power of 4. And we know that I net is 390. So 390 over sigma to the fourth root is equal to the temperature. So if we solve this, put this on our calculator, what do we get? We get 287.98 Kelvin. And that's our answer. Okay, thank you for watching. Please like and subscribe. If you have any questions, leave it down below and I'll answer it as soon as possible. Thank you for watching.